Hi students, welcome to our physics channel Physics Star. So for JEE mains or advanced, certain topics are a little bit tricky and to understand. Okay, so for that purpose, for them, those who are feeling a little bit difficulty in preparing for those topics, for those people, I'm going to do some videos. Okay, among those videos, one of my favorite topics, that is rotational dynamics. So in that, I'm going to explain instantaneous axis of rotation today. Instantaneous axis of rotation. I think everybody uh, might might be feeling about that instantaneous axis of rotation, how to do those problems and all. A little bit, there will be some conceptual misunderstandings. Okay, for those people, now just follow my video lecture today so that you don't get any doubts in the future, right? So in that, first let us discuss about what is instantaneous axis of rotation. Right. Let's start discussing about instantaneous axis of rotation. Instantaneous axis of rotation. So what is this instantaneous axis of rotation? Now, usually there will be some combination of translatory and rotatory motion when we discuss about some objects. For example, combination of translatory plus rotatory means everybody can easily say that it is in case of rolling, right? It is the best example to understand about the combination of both the motions, translatory as well as rotatory, right? There are few more examples also. Take one rod and apply a certain force at one end. Keep that rod on the horizontal table. Assume that it is a smooth horizontal table. Now you just apply a certain force at one end of it. Then it does not rotate. Okay, it does not only rotate or it does not only translate. Okay, so it will come into a combination of translatory as well as a rotatory motion. Okay, so in order to understand that type of little bit complicated motion, okay, let us discuss about that. What is instantaneous axis of rotation? Means it's a process of finding some axis of rotation, okay, in which we are going to uh, convert, okay, the combination of translatory as well as rotatory motions into a pure rotatory motion. It's nothing but what are we going to do here? We are going to convert the combination of we are going to convert the combination of translatory and rotatory motions, rotational motion, into a pure rotatory motion. How is it possible? It is only at a particular instant of time we can do. At that particular instant only we can do. It's a pure, it is that's why we are taking that as instantaneous axis of rotation. See, what happens at the next instant of time? In one instant, we may get one axis of rotation, and in the other instant, we may get another axis of rotation. So whatever we are choosing the axis of rotation here in order to convert them into a pure rotatory motion, that axis of rotation is not constant. Axis of rotation will be continuously changing according to the given situation. Let us take some examples how to find the instantaneous axis of rotation. So once if you go through those examples, you can easily understand. Let us take the first example. Consider a sphere. Consider a sphere. Let us assume that its linear velocity is v, means its velocity of center of mass is v, as well as its rotational velocity is omega here. So it is having both the motions at a time, means it is rotating as well as it is translating, which we used to call it as rolling motion. Am I right or not? So in this, suppose if omega is equal to, if you consider that omega as a pure rolling, I mean, if you consider that, object is in pure rolling, then we can say that here at the bottom, the point which is in contact with the floor, uh, at this point, it will have a net velocity which is equal to 0 when it is in pure rolling, right? So what does it mean? It means that at this point, it will have two different velocities, that is velocity of center of mass as well as the rotational velocity, that is r omega. Both will be in opposite directions. Am I right or not? So finally, we can say that, or we can solve these type of problems by taking P as the axis of rotation at that instant. Yes or no? At any instant, we can take the P as the axis of rotation. Yes or no? And the point P on that surface of the object will be continuously changing. That point P will not be same point at all the times, right? That point P will be changing. So once if this point is in contact, and in the next instant of time, this point will be in contact with the floor. And in the next instant, this point will be in contact with the floor, right? So this point P is the instantaneous axis of rotation at that instant. At that instant only we are taking. For example, if the same rolling object will have a velocity, will have a rotational velocity, angular velocity, omega is equal to, consider V by 2R. Omega is equal to V by 2R. Usually we will take V by R, right? In case of pure rotation. If it is V by 2R, means rotation is greater than translatory motion. Yes. In that case, how to consider the axis of rotation? How to consider the axis of rotation? Observe here carefully. Okay. So in such case, we used to take from that particular velocity here, from that velocity of center of mass, if we draw a perpendicular line, then at some point P, this instantaneous axis of rotation lies. Means at that instant, this point P will be with respect to this point, with respect to this point, the total object will be rotating at that instant of time, not at the next instant. By the next instant, automatically another point will come into contact. Okay. So at that instant only we are calculating. Can you tell me what is the distance from center to this point P? The distance from the center to this point P, is how much? Can you tell me? It is 2R. It is 2R. At that point, or at that instant of time, then omega can be written as V by 2R. Understand? What we have done in order to get instantaneous axis of rotation, just we are drawing one perpendicular line. Okay. And let us take another example. Suppose there is a rigid body. And in that rigid body, we are taking two different points. Consider this point is A and this point is B. Now, point A is actually moving in one direction. Consider this velocity is VA. And point B is moving in another direction. Okay. You may assume that these two are parallel. But these two are not parallel there. These are in different directions. Like this is in another direction. Let us consider. This is VB. Means every particle, all the particles' velocities are in different directions in this object. Okay. In such case, how to find the instantaneous axis of rotation? Means I have taken two different points. So for that purpose, what I'm going to do is I'm going to just draw perpendicular lines of VA and VB, perpendicular lines to VA and VB. What am I drawing? I'm drawing perpendicular lines. First, let us draw a perpendicular line to VA. This is a perpendicular line to VA. And another perpendicular line to VB. Another perpendicular line to VB, that is this one. Yes or no? So I have drawn two perpendicular lines. And these two perpendicular lines are meeting at one point. At this point, we can say that the instantaneous center of rotation exists. This point is called as instantaneous center of rotation. Even here also, this point is called as instantaneous center of rotation. Means with respect to that point, the total object is rotating at that instant. Okay, with respect to that point. With respect to that point, those two objects, the angular velocity of those two objects will be equal. It means that the angular velocity of A, which is equal to angular velocity of B, point B, with respect to P at that instant of time. This is what we call instantaneous axis of rotation. This is called as instantaneous axis of rotation. Okay, let us do, if we do some problems, then you can easily understand. Now, let us discuss one more example. Okay. See, suppose if we consider a wall, this is a wall, and a horizontal surface like this. If we consider a horizontal surface like this, now assume a rod which is kept against the wall of the rod is kept against the wall like this, means it is kept inclined. Okay. Now, usually if two surfaces are smooth, let us assume if two surfaces are not having any friction, then what happens? What happens? The total rod will fall down. It means that at another instant of time, the same rod will be like this. Am I right? The same rod will be like this at another instant of time. So, however, if we take at two different instants, okay, this is one instant and this is the other instant. At two different instants, if we find out the instantaneous center of rotations or instantaneous axis of rotations, then listen here, I'm going to draw two perpendicular lines for the first case. This is the first case and this is the second case. In the first case, what am I going to draw here? This rod comes down. Am I right or not? Center of gravity or center of mass moves in the downward direction. Okay, now. And this end, the lower end, okay, will move in rightward direction. The lower end will move in rightward direction and the upper end will move in the downward direction. Okay. If we draw the perpendicular lines for those two different velocities, do these two velocities same or these two velocities same? Not at all. Already we have calculated the velocities in Newton's laws. Okay. Relation between the velocities. Suppose if this point has a velocity VA and this point has a velocity VB, we have calculated the relation between VA and VB in general constraints. Am I right or not? So let us say if it is VA and VB, now at that instant of time, if we are finding out the axis of rotation, instantaneous axis of rotation, we need to draw two perpendicular lines from VA and VB. Now VA and VB both are meeting at this point. And how is the rod rotating in anti-clockwise direction with respect to us? Am I right? So with respect to us, as we see, as we are observing that it is rotating in anti-clockwise direction, right? That's why at this point, with respect to this point, these two points will be rotating in anti-clockwise direction like this. If we want to find the angular velocity at that instant of time, we need to consider this axis of rotation. If we want to find the angular velocity, let us find that later. Okay. But as of now, I'm just saying the concept. This is omega with respect to this axis of rotation. Now, when it is at the second case, when it is in second case, now again what we have to do? We need to draw two perpendicular lines again. This is one perpendicular line. Yes or no? And this is another perpendicular line. So again, we are drawing two perpendicular lines. Okay, for two different velocities. So again, at this point, one more instantaneous center of rotation exists. Okay, what does it mean? It means that as the object is moving, okay, na, ICR may change. It will not be at the same position. That's why we are saying it as instantaneous. Okay, so with respect to this point, it may be having velocity omega dash. Understand this type of motion? Okay, na? Or else let us say one more example. Take a rod. Here, let us consider a rod. Let us consider a rod here and assume that the upper end of the rod is moving. The upper end of the rod is moving with a velocity 2v, and the lower end of the rod is moving in this direction with certain velocity v. Usually, if both are 2v, then it only rotates. Am I right or not? But here, the upper end of that is moving with the velocity 2v, and the lower end of it is moving with the velocity v. Hence, okay, hence it will have the combination of translatory as well as rotatory motion, right? That's why let us suppose this is a center of mass of the rod. So what I have to do in order to find the instantaneous axis of rotation means just join these two vectors, 2v and v. Just join these two vectors. Here, this is how I am going to join these two vectors like this. Now, this is that point, instantaneous center of rotation or instantaneous axis of rotation. This is instantaneous center of rotation. Do you understand? Okay, this is how we are going to find out the instantaneous axis of rotation in different cases. Let us see one example problem so that you can understand how to do this kind of problems. Just a minute. Yes. Let us do this. Once observe this problem. Right. So a rod AB of length L leaning against a smooth vertical wall and a smooth horizontal surface. Now, lower end A of the rod is pulled with a constant velocity V. Okay, lower end is pulled with a constant velocity V. In consequence, the upper end starts sliding against the wall, and the rod rotates in vertical plane. Vertical plane means axis. The plane will be vertical plane. Okay. Axis is a horizontal axis at that instant. Okay. Then locate the position of instantaneous center of rotation of the rod when it makes an angle theta with the vertical, and find the angular velocity of the rod. We need to find the angular velocity of the rod. Locating the instantaneous center of rotation, just now we did, right? What we have to do? See, this is a wall and this is a surface. Now, for this, one rod is kept against a vertical wall like this. This is a rod now. Now, the lower end is moving with a velocity. Lower end is moving with a velocity v. Lower end A it is, and it is this point is B. So that the upper end will be coming down with a velocity VB. Okay. Now what I have to do in order to find the center of instantaneous center of rotation? We need to draw two perpendicular lines. And the point where those two perpendicular lines are intersecting, that at that point, the instantaneous center of rotation exists. See, now I am going to draw two perpendicular lines. This is one perpendicular line drawn at VB and the other perpendicular line drawn at the point A. Okay, so these two points, these two perpendicular lines are meeting at this position, right? This is ICR, instantaneous center of rotation. Now, he has given that if it makes an angle theta with the vertical, if it makes an angle theta with the vertical. Now, what I have to do? What I should find now? We need to find the angular velocity of the rod. So, how to find the angular velocity of the rod? Okay, I think we can relate VA and VB, right? Where did we discuss that? In Newton's laws, in general constraints, we have discussed. You might have studied that in general constraints, in Newton's laws, right? Constraint equations. In that, how to relate VA and VB? Just for discussion, just tell me how to relate VA and VB. It means now I'm going to take this distance as X at that instant, and the distance is Y at that instant. So the length of this rod is L, so that X square plus Y square is equal to L square. Okay, now what am I doing? I'm just taking I'm differentiating this X and Y with respect to time, distances with respect to time, so that I'm going to get the velocities, right? 2x into dx by dt. Dx by dt means what? Vx means velocity along x-axis, plus 2y into dy by dt. It is vy, velocity along y-axis. If we differentiate this length L, I'm going to get 0 because L is constant. Therefore, 2x into vx is equal to 2y into vy. Forget about negative because it is coming in the downward direction. No? So obviously we have to take minus here. If it comes to right side, it will become positive. So therefore 2 gets cancelled. Then what happens? Here x by y is equal to vy by vx. Yes or no? X by y is equal to vy by vx. And what is vy here? In y direction, which velocity is there? Vb. In x direction, which velocity is there? Va. Va means what? V. Va means what? V just. It is given. Yes or no? So therefore, we can relate VB and VA as VB is equal to V into, okay, what is X by Y? In this, at this instant, X by Y means opposite side by adjacent side. Therefore, you will get tan theta. This is VB and VA relation. This is in case of general constraints. Now let us discuss about the angular velocity. Okay, let us discuss about the angular velocity. So angular velocity means with respect to this end, with respect to this instant of instantaneous center of rotation, we are going to calculate the angular velocity here. Means which velocity we will consider, either VB we can consider or V we can consider, no problem, anything. So I'm going to take first VA divided by its perpendicular distance. Now what is its perpendicular distance? This one. Yes or no? This is its perpendicular distance. Can you tell me what is that perpendicular distance in terms of L? In terms of L, that is L cos theta. Am I right or not? In terms of L, it is written as L cos theta. Yes or no? Omega is equal to VA by L cos theta. So this is how to find is omega is angular velocity of VB also same or different? Definitely same. So you can also write it as omega is equal to VA value, it is given as V by L cos theta. Again, if you find it for VB, you'll get the same value, V by L cos theta only. Understand? Now, let us discuss one more problem. Let's discuss one more problem. Yes. Now see this problem. See this problem. A cylinder of radius capital R is rolling without sliding between two horizontal planks 1 and 2 as shown in the figure. If the velocities of the planks A and B or V and 2V respectively, find the position of instantaneous center of rotation and B angular velocity of the cylinder. So in between these two planks there is a cylinder. Okay. Now what is the radius of that cylinder? R. So I am just drawing the planks. This is one plank, and in between the two planks the cylindrical object is there, which is able to roll, okay, without sliding. Means it will be in pure rolling in between these two planks. Consider this is to V velocity and this is V velocity. Okay, let us draw it bigger because it is 2V now. It is 2V velocity. Now observe this carefully. If I add these two velocities, if I add the tips of these two velocities, then we are going to get like this. Am I right or not? See. Is it passing through center? No. Yes or no? It is not passing through center. That's why this, suppose if we join, if we take the diameter, vertical diameter, then this point is the instantaneous center of rotation or instantaneous axis of rotation. Means when these two are moving with 2v and v velocities. So with respect to that instantaneous axis of rotation, we are going to calculate what? Angular velocity of the cylinder. Okay. So let us draw that first. I'm drawing it in a bigger way. So this is 2r. I'm taking this as 2r. Means this vertical line is there, no, that I'm drawing it is 2r. And for the diameter, this is a center for that cylinder, center of the cylinder. Now at this point, there are two different velocities, right? At the topmost point, it is 2v velocity, and at the bottommost point, it is v velocity. Now if we add these two, somewhere, pardon, I'm not able to draw that straight line, right? So consider this value is x. This value is x. Okay. And can you tell me what, I mean, this point is instantaneous center of rotation. With respect to point P, the topmost point, that is A, consider A and this is B. With respect to point P, is the angular velocity same of A and B? Definitely. Already I told you, right? Okay. So with respect to point P, now what we are going to do is omega A with respect to point P is equal to omega B with respect to point P. Yes or no? Now, what is omega angular velocity of A with respect to this P? Now we can write V by R, right? V means what? 2V by R value is how much? R value means perpendicular distance. Perpendicular distance is how much from A to that point P? Perpendicular distance is R plus X. Observe here carefully. It is R plus X. Am I right or not? From center to this point, it is R. And from the center to this point P is X. So that it is R plus X. Then again, at point B, the velocity is V divided by what is a distance? What is the distance here? Perpendicular distance. That is R minus X. Here V gets cancelled. Therefore, 2 into R minus X is equal to R plus X. Hence 2R minus 2X is equal to R plus X. Send this minus 2x to this side so that it will become 2x plus x. It is 3x, which is equal to capital R. Yes or no? And therefore, x is equal to R by 3. Okay, now we have got the distance from the center. Distance of instantaneous axis of rotation from the center is x is equal to R by 3. Now, how to find this omega now? Therefore, angular velocity is equal to for point A, if we calculate 2v by how much is the distance now? R plus x value R by 3. So we are going to get 3 into 2, 6v divided by 4r. Hence, if we simplify this, you will get 3v by 2r. Therefore, what is the angular velocity? 3v by 2r. Okay. This is with respect to that particular instant, instantaneous axis of rotation. Okay. This is how we have to do these problems. And in the next class, I'll tell few more problems based on this instantaneous axis of rotation. So keep watching my channel. to have a continuation of topic. Thank you all. Have a nice day. Go for a good preparation. Don't waste your time because it is a crucial time, right? Thank you all. Bye, everybody. And please like, share, and subscribe to my channel, Physics Star. Thank you.